Today we're going to start section 8.2, which is law of sines. We use SOHCAHTOA to solve problems involving right triangles. Whenever we take the sine, cosine, and tangent in a diagram, it's always of one of the acute angles in a right triangle. In this section 8.2 and again in 8.3, we're going to look at ways to use the trig functions, specifically sine and cosine, to find missing sides and angles of triangles that are not right triangles. There are certain cases where you can use those functions and specific formulas in order to find missing sides and angles. So today we're going to work with what's called the law of sines, and I'm going to show you where this formula comes from because it's one that we can kind of derive pretty easily. And I have this diagram with triangle ABC that is not a right triangle. So we would not be able to use trig in this big triangle. But we've drawn an altitude from C down, which makes it perpendicular to the side. So when I look at one of these smaller triangles, I have two right triangles. If I look at the triangle on the left, I could use trig with this angle A. H is for the height of the altitude because H is always used for height of a triangle, which is the length of the altitude. B is the side that's opposite of angle B, A is the side that's opposite of angle A, and C is the side that's opposite of angle C. So if we look at this small right triangle, we have the opposite side and the hypotenuse. We could say the sine of angle A is the length of the opposite side divided by the hypotenuse of that small right triangle. Then I could look at this right triangle on the right side. Here, I have H and I have A, and I can look at it from the perspective of angle B. Angle B, H is opposite and A is the hypotenuse. So the sine of angle B is H over A. I'm going to take each of these equations and solve them for H. So on this side, I'm going to multiply both sides by B. So I get B times the sine of A equals H. Over here, I'm going to multiply both sides by A. A times the sine of B equals H. Since both of these are equal to H, I can set them equal to each other. And again, as you go through this, remember, lowercase letters are side lengths, capital letters are angles. And I get this equation, B times sine of A equals A times sine of B. Typically what we do is divide both sides by both A and B, the lengths of those two sides. And over here, the B's cancel out. And over here, the A's cancel out. And I get the equation, sine of A over A equals sine of B over B. This is 2/3 of the law of sines. It's actually a very easy formula to remember. If we were to draw in an altitude from one of the other angles, we could write in another equation and we would get the third part of this. We're going to jump right to the final part. The law of sines states that the sine of A over A equals the sine of B over B equals the sine of C, angle C, over C. Basically, what we're saying here is that in any triangle, the ratio of the sine of an angle divided by the length of the side opposite of it is equal throughout the triangle. The letters may not be the same in every problem. Not every triangle is labeled A, B, C. It's always sine of an angle divided by the length of the side opposite that angle. Angle B is opposite side B. Angle C is opposite side C, so that we make sure that we plug in correctly. As you go through this section, and again, the whole chapter, make sure your calculator is in degree mode. Remember, if the batteries die, it's going to reset to radians. So here's a couple examples of how you can use law of sines. In this case, we're looking at a triangle where we're given angle, angle, side, which if you remember from geometry is a way to prove two triangles congruent. So that means that there's only one triangle that has these two angles and that side. So here, I'm going to try and solve the triangle. I'm going to find all the missing sides and angles. The first thing that we can find pretty easily is angle C, because we know that the angles of a triangle add up to 180. So I'm going to take 180 minus 59 and minus 38 to get that the measure of angle C is 83 degrees. Now, without the law of sines, that would be all that we could do. But now that we have law of sines, I have an angle and a side opposite of it that I know the values of both. You always have to know one opposite side and angle in order to use law of sines. I'm going to plug into law of sines by filling in a fraction that I know both values. The sine of 59 over 350. And then I'm going to pick what I find next. So if I want to find the length of B, B is opposite the 38 degree angle. So sine of 59 over 350 equals sine of 38 over the length of side B. I'm going to take this equation and solve it for B. You can think of this, remember when you had a proportion, you cross multiply and multiply the sine of 59 by B, and I multiply the 350 times the sine of 38. And then I need to get this B by itself, so I'm going to divide both sides by sine of 59. And this is what I would put in my calculator right here. 350 times sine of 38 degrees divided by sine of 59 degrees, and it would give me the length of B, which we're going to round to 2 decimal places, and I get that B is 251.39, and the units in this problem are centimeters. If they give you units, put units in your answers. So now we have 2 lengths. And if you remember from geometry, larger angles are opposite longer sides. 59 is opposite 350, so 38 opposite 251 is a reasonable answer. Now I want to find the length of side C. I'm going to set up the same proportion, only instead of doing sine of A over A equals sine of B over B, I'm going to do sine of A over A equals sine of angle C over the side length of side C. And we're going to solve it the same way. I'm going to cross multiply C times sine of 59 equals 350 times sine of 83, and divide both sides by sine of 59. After you do this a couple times, you may find the pattern and be able to jump straight to what you put in the calculator. You're always going to show what you've plugged into the formulas and then any other work you need to. So in your homework, it should be seeing this law of sine equation, and then you can show more work, or if you can go straight to the answer, that's fine. When I put this into my calculator, I get that C is 405.28 centimeters. So now I've solved the triangle. I found all the missing sides and the missing angles. And again, 405 is the longest side. 405 is opposite of 83, which is the largest angle. That makes sense. One more example, and in this case, I'm not given a diagram. Here, this is the angle side angle case, where the side is between the 2 angles you are given. And we have a triangle with angle A is 40, angle B is 20, and A is opposite which is opposite the A is 2. I'm just going to sketch a picture. You don't have to, but it might be helpful. I have a triangle with a 40-degree angle and a 20-degree angle. I'll label those. This is the 40, that's A. The 20, and I'm not very well drawn to scale, is B. A has to be opposite of angle A. This is going to be side C, or angle C, side C, and side B. B is opposite B, C is opposite C, A is opposite A. And with triangles, anytime we know 2 angles, we can find the third angle by subtracting from 180. 180 minus 40 minus 20, angle C is 120 degrees. Then we want to find the missing sides. So I'm going to put the 120 here. Notice it doesn't matter that that's an obtuse angle. We can still use law of sines. And I'm going to look for the pair of angles and sides that are opposite of each other that we know. In order to use law of sines, I have to be able to plug in to one of those ratios completely. Sine of 40 over 2 equals sine of 20 over B. Or if I want to find C, sine of 40 over 2 equals sine of 120 over c. This is the work you have to show in your homework and when we do our graded assignment. Then you're going to solve these equations to find the missing length. So again, I cross multiply and divide by the sine of 40. And I get that B in this triangle should be 1.06. There's no units given, so I can just leave it like that. B is shorter than A because it's opposite at angle that's smaller. Over here, C times sine of 40 equals 2 times sine of 120. And I divide both sides by sine of 40. And I get that the length of side C when I go to my calculator is 2.69. C is the longest side because it's opposite of the largest angle. Again, show your law of sines equations and show your final answers. Tomorrow, we're going to look at how you can use law of sines in some cases to find missing angles.